Today we'll be doing the integral from 0 to 1 of the natural log of 1 plus x squared divided by 1 plus x dx. And to start off, we'll place a parameter. So we'll call our function I of s, and it's the integral from 0 to 1 of the natural log of 1 plus sx squared divided by 1 plus x dx. And we're going to notice that I of 0 will yield 0, and I valid at 1 will give us our integral I. So now differentiating both sides, we have that I prime of s is the integral from 0 to 1 over 1 plus x, the derivative with respect to s of the natural log of 1 plus sx squared dx. So we have the integral from 0 to 1 over 1 plus x times 1 over 1 plus sx squared, then the derivative with respect to s of 1 plus sx squared dx. So I prime of s is integral from 0 to 1 of 1 plus x times 1 plus sx squared, and then the partial derivative with respect to s of this will be x squared dx. And then from here we will perform partial fraction decomposition. So from here we'll have a over 1 plus x plus bx plus c divided by 1 plus sx squared will be our integrand. X squared divided by 1 plus x times 1 plus sx squared. So getting common denominator, we have that a times 1 plus sx squared plus 1 plus x times bx plus c equals the numerator x squared. So expanding this, we have that a plus asx squared plus bx plus c plus bx squared plus cx equals x squared. And we'll factor a bunch of terms. So we have a x squared as plus b. Then factor out an x, we have plus x times b plus c. And then the remaining constants plus a plus c equals x squared. So we'll notice that as plus b must equal to 1, b plus c must be 0, and a plus c must also be 0. But this tells us that b equals negative c and a equals negative c, but this also means that a equals b. So that also means that bs plus b equals 1, which yields that b equals 1 over s plus 1. But we said a equals b, so a equals 1 over s plus 1. And from here, negative b equals c. So c equals negative 1 over s plus 1. We now have that from our partial fractions decomposition. We have the integral from 0 to 1 of a over 1 plus x plus bx plus c divided by 1 plus sx squared. And we just found out that a equals 1 over s plus 1, and b equals 1 over s plus 1, and c equals negative 1 over s plus 1. So plugging this into our integrand, we have that I prime of s is the integral from 0 to 1 of 1 over s plus 1 times 1 over 1 plus x, and then plus 1 over s plus 1x minus 1 over s plus 1 divided by 1 plus sx squared. All of this with respect to dx. So we could factor out a 1 over s plus 1. So we have a I prime of s, the integral from 0 to 1 over s plus 1 times 1 over 1 plus x plus 1 over s plus 1 x minus 1 divided by 1 plus sx squared. All of this with respect to x. And we could break apart this even further. So we have I prime of s is the integral from 0 to 1 of 1 over s plus 1 times 1 over 1 plus x plus 1 over s plus 1 times x over 1 plus sx squared, and then a minus 1 over 1 plus sx squared dx. And distributing this further, we have that I prime of s is the integral from 0 to 1 of 1 over s plus 1 times 1 over 1 plus x plus x s plus 1 times 1 plus sx squared, and then minus 1 over s plus 1 times 1 plus sx squared dx, and a factor of 1 over s plus 1 term out of the integral. So we have I prime of s will be 1 over s plus 1, the integral from 0 to 1 over 1 plus x dx, and then plus 1 over s plus 1, the integral from 0 to 1 of x divided by 1 plus sx squared dx, and we'll have a minus 1 over s plus 1, the integral from 0 to 1 of 1 over 1 plus sx squared dx. We now have that our I prime of s expression is in terms of 3 integrals, and now we will evaluate each one. So for the first one, we have the integral from 0 to 1 over 1 plus x dx, but that's just going to be the natural log of 1 plus x from 0 to 1, which is the natural log of 2. So I prime of s is log 2 over 1 plus s plus 1 over s plus 1, the integral from 0 to 1, x divided by 1 plus sx squared, minus 1 over s plus 1, the integral from 0 to 1 divided by 1 plus sx squared dx. And for the second integral, we have the integral from 0 to 1, x divided by 1 plus sx squared dx. And from here, we'll make a substitution. So we'll let u equal 1 plus sx squared, which means that du divided by s times 2x equals dx. And at the bounds, u sub 1 will be 1, and u sub 2 will be 1 plus s. So it's equal to the integral from 1 to 1 plus s of x divided by u du divided by s times 2x. The x's will cancel. We're left with 1 over 2s, the integral from 1 to 1 plus s of 1 over u du, which is 1 over 2s, the natural log of u from 1 to 1 plus s. That's going to yield 1 over 2s times the natural log of 1 plus s. So we now have that I prime of s is log 2 divided by s plus 1 plus 1 over s plus 1 times log of 1 plus s divided by 2s, and then minus 1 over s plus 1, the integral from 0 to 1 divided by 1 plus sx squared. And for the third integral, we have the integral from 0 to 1 divided by 1 plus sx squared dx. And we'll notice that 1 plus sx squared can be written as 1 squared plus the square root of sx quantity squared. So we have the integral from 0 to 1 divided by 1 squared plus square root of sx squared dx. And we'll just make a substitution. So we'll let u equal square root of s times x, which means that du equals square root of s dx. But solving for dx, we have that du divided by the square root of s equals dx. And that u sub 1 will be 0, and u sub 2 will be the square root of s. So is equal to the integral from 0 to the square root of s, 1 over 1 plus u squared du divided by square root of s, which is 1 over the square root of s, the integral from 0 to the square root of s, 1 over 1 plus u squared du, which is 1 over the square root of s, inverse tangent of u from 0 to the square root of s, which is 1 over the square root of s, inverse tangent of the square root of s. So I prime of s will be the natural log of 2 divided by s plus 1 plus log of s plus 1 divided by s plus 1 times 2s, and then minus 1 over s plus 1 times 1 over the square root of s, inverse tangent of the square root of s. So we just got done showing that I prime of s is the natural log of 2 divided by s plus 1 plus 1/2 the natural log of s plus 1 divided by s times s plus 1 minus the inverse tangent of the square root of s divided by the square root of s times s plus 1. And then from here we will retrieve the I of s, but we have to integrate with respect to from 0 to 1. So the integral from 0 to 1 of I prime of s will be the natural log of 2, the integral from 0 to 1, 1 over s plus 1 plus 1/2, the integral from 0 to 1, the natural log of s plus 1 divided by s times s plus 1, and minus the integral from 0 to 1, the inverse tangent of the square root of s divided by the square root of s times s plus 1. And then this integral will be I of s from 0 to 1, which is the natural log of 2, the integral from 0 to 1, 1 over s plus 1 plus 1/2, the integral from 0 to 1, the natural log of s plus 1 divided by s times s plus 1, minus the integral from 0 to 1, the inverse tangent of the square root of s divided by square root of s times s plus 1. But evaluating at the limits, we have I of 1 minus I of 0 equals the natural log of 2, the integral from 0 to 1, 1 over s plus 1, plus 1/2, the integral from 0 to 1, the natural log of s plus 1 divided by s times s plus 1, minus the integral from 0 to 1, inverse tangent of the square root of s divided by the square root of s times s plus 1. But recall that I of 0 is 0 and I of 1 will be our integral. So our integral will just simplify into the natural log of 2, the integral from 0 to 1, 1 over s plus 1 ds, plus 1/2 the integral from 0 to 1, the natural log of s plus 1 divided by s times s plus 1 ds, minus the integral from 0 to 1, the inverse tangent of the square root of s divided by the square root of s times s plus 1 ds. And from here I will focus on this first integral. So the first one will be the integral from 0 to 1, 1 over s plus 1 ds, which will be the natural log of s plus 1 from 0 to 1, which is the natural log of 2. So our integral will become natural log of 2 times the natural log of 2. So we have the squared natural log of 2 plus 1/2 the integral from 0 to 1, the natural log of s plus 1 divided by s times s plus 1, minus the integral from 0 to 1, inverse tangent of the square root of s divided by square root of s times s plus 1 ds. And I will focus on the inverse tangent integral. For the second one, we have the integral from 0 to 1, inverse tangent of the square root of s divided by the square root of s times s plus 1 ds. We'll make a substitution. We'll let u equal the square root of s, which means that u squared equals s, which also means that 2u du equals ds. And the bounds of integration won't change here. So we have the integral from 0 to 1, the inverse tangent of u divided by u times s is u squared. So we have 1 plus u squared, and ds is 2u du. So 2u du. These will cancel. We're left with twice the integral from 0 to 1, inverse tangent of u divided by 1 plus u squared du. And yet again, we can make another substitution. So we'll let v equal the inverse tangent of u, which means that dv equals 1 over 1 plus u squared du. And then the bounds v sub 1 will be 0, and v sub 2 will be pi over 4. So it's equal to twice the integral from 0 to pi over 4 of v dv, which is 2v squared over 2 from 0 to pi over 4. These cancel, and we're left with pi over 4 quantity squared, which is pi squared over 16. So we finally have that our integral is the squared logarithm of 2 minus pi squared over 16 plus 1/2 the integral from 0 to 1, the natural log of s plus 1 divided by s times s plus 1 ds. So we'll focus on the last integral. So for the third one, we have 1/2 the integral from 0 to 1, the natural log of s plus 1 divided by s times s plus 1 ds, and we will use partial fractions again. So 1 over s times s plus 1 can be decomposed into a over s plus b over s plus 1. So getting common denominator, we have a times s plus 1 plus b times s equals 1, which means that as plus a plus bs equals 1. Factor out an s, we have s times a plus b plus a equals 1. But this means that a plus b must be 0 and a has to be 1. But solving from here, we have a equals negative b, and that means that negative a equals b, but a is 1, so we have b equals negative 1. So this means that we have 1/2 the integral from 0 to 1, the natural log of s plus 1 divided by s, then minus the natural log of s plus 1 divided by s plus 1 ds. Now we could distribute. So we have 1/2 the integral from 0 to 1, the natural log of s plus 1 over s minus 1/2 the integral from 0 to 1, the natural log of s plus 1 divided by s plus 1. And I'll focus on this inner integral. So the integral from 0 to 1 of the natural log of s plus 1 over s. We use the series expansion of the natural log of s plus 1. So it's equal to the integral from 0 to 1, 1 over s, then the sum from 1 to infinity, negative 1 to the k minus 1, s to the k over k. And exchanging the sum and integral, we have the sum from 1 to infinity, negative 1 to the k minus 1 over k, and then the integral from 0 to 1, s to the k minus 1 ds, which, if you do that integral, we have the sum from 1 to infinity, negative 1 to the k minus 1 over k squared. This is the eta function at 2, which we know will be pi squared over 12. So we now have that is equal to 1/2 times pi squared over 12, and then a minus 1/2 the integral from 0 to 1, the natural log of s plus 1 divided by s plus 1 ds, which is equal to pi squared over 24 minus a half, the integral from 0 to 1, the natural log of s plus 1 divided by s plus 1 ds. So this is equal to pi squared over 24 minus a half, the integral from 0 to 1, natural log of s plus 1 divided by s plus 1. And we'll make a substitution. We'll let u equal the natural log of s plus 1, which means that du will be 1 over s plus 1, and that the bounds will be u sub 1 will be 0, and u sub 2 will be the natural log of 2. So we're going to have that pi squared over 24 minus a half, the integral from 0 to the natural log of 2 of u du, which is pi squared over 24 minus a half u squared over 2 from 0 to the natural log of 2, which is equal to pi squared over 24 minus 1/2 of the squared logarithm of 2 divided by 2, which is equal to pi squared over 24 minus 1/4 the squared logarithm of 2. So we have their integral is the following expression, and now all that's left is to combine like terms. So the squared logarithm of 2 minus 1/4 the squared logarithm of 2 will simplify into 4 the squared logarithm of 2 minus the squared logarithm of 2 divided by 4, which is equal to 3 squared logarithm of 2 divided by 4. And that negative pi squared over 16 plus pi squared over 24 will equal negative pi squared 16 is the same thing as 8 times 2 plus pi squared, and 24 is the same thing as 8 times 3. So if we multiply 3 here and a 2 here, we'll be left with negative 3 pi squared plus 2 pi squared divided by 8 times 3 is 24, and 24 times 2 is 48. So we're left with a negative pi squared over 48. And then combining this term and this term, we now have that our integral will be 3 squared logarithm of 2 divided by 4 minus pi squared over 48, which is equal to the integral from 0 to 1, the natural log of 1 plus x squared divided by 1 plus x dx. And so this is the final result. Thank you very much for watching.